Hello everyone, this is Mr. Gazzato. Today's learning target on this worksheet is to prove that a function is even, odd, or neither. So the definition of even, I'm going to highlight it in yellow. A function is even if f of x equals f of negative x for all x in the domain. We saw in the Desmos that even functions are symmetric to the y-axis. Odd functions, the definition that I'm highlighting in green, f of x equals opposite of f of negative x, and we saw that odd functions are symmetric to the origin. So here we want to justify or prove functions are even, odd, or neither. So for this video we'll go through some of the odds on this page, and then for practice you can try the other problems that are not in this video. So we're going to start with problem number 33. So f of x is equal to 4x cubed. You may already have an idea that this function is odd, even, or neither based on the graph. But to prove it, we're going to go through a couple steps. So step one is we're going to calculate f of negative x. So that's 4 times negative x quantity cubed, which is negative 4x cubed when you do the math. Step two, the opposite of f of negative x. So we just calculated f of negative x, so we're going to take the opposite of our previous answer, because what I just highlighted in blue is f of negative x. So it's the opposite of negative 4x cubed, and doing that math, you get 4x cubed. So when you look at this, you should be able to tell that f of x is not equal to f of negative x, but in fact, that if you look at f of x, you should be able to tell that that's equal to the opposite of f of negative x. Therefore, the function is odd. So this is a little three-step proof. Step one, I'm going to put a star next to it, is you calculate f of x. Step two, you calculate the opposite of f of negative x. And then you have to check where I'm putting these two bullet points, which one is true. If one of them is true, then it's even or odd. If both of them are false, then it's neither. Let's take a look at another example. We'll look at example 35. So problem 35 says g of x is equal to 3x squared minus 5. So step one, I'm going to calculate g of negative x. So that's 3 times negative x squared minus 5, which is 3x squared minus 5. I'm going to go through this, even though at this point I do see that g of x is equal to g of negative x. Therefore, these three dots often mean therefore in math. So therefore, g of x is even. But I'm going to go through the odd just to show that it's not odd. So opposite of g of negative x. So that's the opposite of 3x squared minus 5. And when we distribute, we get negative 3x squared plus 5. And hopefully you can tell that g of x is not equal to the opposite of g of negative x. Therefore, g is not odd. Now there's not too many functions that are both even or odd. You could ponder that. You could see if you could find any functions that are both even or odd, and we'll discuss that in class. Let's go through a couple more problems. Number 37. So 37 says f of x is equal to the cube root of x. So step one, I'm going to calculate f of negative x. So that's the cube root of negative x. The cube root of negative 1 is negative 1. So this is the opposite of the cube root of x. Step two, I'm going to calculate the opposite of f of negative x. So the opposite of negative cube root of x. The two negatives make a positive, so you get the cube root of x. So therefore, g of x is not equal to the it's not g of x. F of x is not equal to f of negative x, so f is not even. However, we can see that f of x is equal to the opposite of f of negative x, so f is odd. Okay. Our next problem we're going to look at is number 39, which has some absolute values in it, so that's a little bit different. If you want to pause the screen and try one of these on your own before I go through it, that's perfectly fine. So f of x is equal to x plus the absolute value of x. Again, if you want to pause the screen and try it, otherwise you can watch. So f of negative x is equal to negative x plus the absolute value of negative x. And the absolute value of negative x is the same as the absolute value of negative 1 times the absolute value of x. Therefore, this becomes negative x plus the absolute value of x. I want to write down what I just said verbally over here. The absolute value of negative x is equal to the absolute value of negative 1 times the absolute value of x. So then that's 1 times the absolute value of x, which is the absolute value of x. That's why I can replace what I'm highlighting here in yellow with the absolute value of x. Okay, so when we look at these, we can tell that it's not even. So step 2 is I need to calculate the opposite of f of negative x. So that's the opposite of parenthesis negative x plus the absolute value of x. And that's going to become x minus the absolute value of x. So when I compare f of x, as I said earlier, is not the same as f of negative x. So f is not even. And when I compare f of x to the opposite of f of negative x, those aren't equal either. So f is not odd. So if the function is not odd or even, then we're going to say f of x is neither. So that's the answer to that one. Okay, we're going to try problem number 41. So problem number 41, and if you want to pause the screen after I write the question, feel free to do that. So 41 says g of x is equal to x squared plus 3 over x squared minus 1. So the first step, I need to calculate g of negative x. So that's negative x squared plus 3 divided by negative x squared minus 1. So that's x squared plus 3 over x squared minus 1. If we compare these two, we can see that g of x is equal to g of negative x. So g is even. Now technically we would want to check that it's not odd, but as I said earlier, not too many functions are both. We'll come back to that. So the opposite of g of x, and I'm purposely doing this in blue, so it's the opposite of x squared plus 3 over x squared minus 1. Now a very common mistake in this problem is people tend to distribute that negative to both the numerator and the denominator, but that's not mathematically true. So if you are going to distribute, you can put that negative in the numerator, like I've highlighted here in yellow. And then if you distribute, you get negative x squared minus 3 over x squared minus 1. And from here, you can tell that that function that I'm going to highlight here in blue is not the same as the original. A very common mistake that we've seen in class is people distribute that negative that I'm going to highlight here in green. People distribute that negative to both the numerator and denominator. That's not true. Here's a numerical example. If we said the opposite of 2/3, that's negative 2 over 3. You could put the negative in the denominator, but you don't say negative 2 over negative 3, just for clarity. So hopefully you can tell that this function is not odd since these are not equal. G of x is not equal to the opposite of g of negative x. so not odd. All right, I think we're going to do maybe one more example here. We'll do number 43. So problem number 43 says h of x is negative x cubed over 3x squared minus 9. So step one, I'm going to calculate h of negative x. So that's the opposite of negative x cubed over 3 times negative x squared minus 9, which is x cubed over 3x squared minus 9. So h of x is not the same as the h of negative x, so h is not even. Now let's check the odd. So step two, what is h of negative x, or excuse me, opposite of h of negative x? So that's the opposite of x cubed over 3x squared minus 9. And as I mentioned earlier, we just distribute into either the numerator or the denominator. Again, last year people distributed to both the numerator and denominator, so we need to avoid that mistake. So when I distribute, you get negative x cubed over 3x squared minus 9. And if you compare, I'm going to highlight this in blue, opposite of h of negative x to the original, you should see that these two are equal. So h of x is equal to the opposite of h of negative x. So h is odd. So the learning target for this particular video was to justify or prove a function is even, odd, or neither. So what we would like you to do, and you can rewind this video as necessary, this will also be posted on the website as a PDF, but we want you to try the odds, or excuse me, the evens here.